In this session, we will take down a problem based on Faraday's law of electromagnetic induction. First, you can take down this question. A rectangular wire loop or you can write rectangular loop of side 8 cm and 2 cm is stationary in a normal magnetic field region. Normal magnetic field region. The current feeding the electromagnet that produces the magnetic field is gradually reduced. The current feeding the electromagnet that produce the magnetic field is gradually reduced so that the field decreases from its initial value of the field decreases from its initial value of 0.3 Tesla at the rate of 0.02 Tesla per second. If the loop has a resistance of 1.6 ohm, if the loop has a resistance of 1.6 ohm, the loop has a resistance of 1.6 ohm, how much power is dissipated by the loop as heat? How much power is dissipated by the loop as heat? Let us read it. A rectangular loop of side 8 cm and 2 cm is stationary in a normal magnetic field region. We have a rectangular loop which is not moving, it's stationary in a normal magnetic field region. The current feeding the electromagnet means we are placing a loop in a magnetic field, or the loop is placed in a magnetic field region. Loop is placed in a magnetic field. The current feeding the electromagnet that produces the magnetic field is gradually reduced so that the field decreases from its initial value of 0.3 Tesla at the rate of 0.02 Tesla per second. Now this magnetic field is gradually reduced, but why? How? By reducing the current which actually produces this magnetic field. That means an electromagnetic is producing a magnetic field here, and the current to that electromagnet is reduced. That means actually we are gradually reducing the magnetic field. Indirectly it says that the rectangular loop is actually kept in a magnetic field which is reducing. If the loop has a resistance of 1.6 ohm, how much power is dissipated by the loop as heat? So for this, first we need to find out what is the current in the loop. Due to change in magnetic field, there gets an induced EMF, or EMF gets induced in the loop, and because it's a rectangular loop, a closed circuit, a current starts flowing and the loop has some resistance, so definitely there will be a heat dissipation. First we will find out what is the induced EMF, and then we can calculate the current because the resistance is given, and calculate the power loss as heat. So we can write the given quantities, given loop size or loop area. We can write area of the loop A as 8 centimeter into 2 centimeter. So I can write 8 into 2 into 10 to the power minus 4. 16 into 10 to the power minus 4 meter square. Convert it into meter. Into 10 to the power minus 4 meter square. And what else is given? Now the initial value of the magnetic field 0.3 Tesla and the rate of change of magnetic field dB by dt is given, which is 0.02 Tesla per second. We know by Faraday's law of electromagnetic induction, the induced EMF is given by d phi by dt, and 5 B into A. Now why the flux is reducing here? Because we are reducing the magnetic field B. So phi is BA, or flux is calculated as the field multiplied by area. So we can write it as d by dt of B into A, and the area of the loop is not changing, therefore it is A into dB by dt. Now let us substitute the values. Area is 16 into 10 to the power minus 4 multiplied by dB by dt, that is 0.02. The answer is 16 into 0.02 is 32 into 10 to the power minus 2, and minus 4 here, therefore it is 10 to the power minus 6 volts. E is 32 into 10 to the power minus 6 volts. This is the induced EMF. Now given the loop resistance, R as 1.6 ohm. Therefore current in the loop, as I is equal to E by R. (32 into 10 to the power minus 6 divided by 1.6), and this gives the value of I is, you can do the calculation, it will come to 20 into 10 to the power minus 6 amperes, or I can write it as I is 20 microamps. The current in the loop is 20 microamps. Now next is the power lost as heat. That is a question. The power lost as heat is given by P is I square R. Power is I square R. 20 into 10 to the power minus 6 whole square into R. R is 1.6. Now this will come around 640 into 10 to the power minus 12. Minus 6 square will give you minus 12. Unit is watts. The power lost as heat is 640 into 10 to the power minus 12 watts. how much power is dissipated by the loop as heat. Now the power dissipated as heat or power lost in the form of heat is given by 640 into 10 to the power minus 12 watts. Power lost as heat is 640 into 10 to the power minus 12 watts. The power lost as heat is 640 into 10 to the minus 12 watts.